board. There we go. If at any point you have questions, please unmute yourself and ask. That's kind of the point of us all being on together, is that if you get stuck on something, you can ask.
Miss Lucia,
Yeah.
it's not letting me attach a photo to the assignment to like submit it.
You can email it just straight to me and skip the Google Classroom part for today.
Okay.
Okay.
Yeah, it seems like I have the same problem. I tried attaching a photo and it didn't work.
I only got bits and pieces of that, Alex, but are you having trouble with Google Classroom too, submitting? Okay. Email me the pictures of your work. For anybody that's having trouble with Google Classroom for today to submit work, you can just email me those pictures. And if you have more issues with that, shoot me an email and we'll figure out a way for me to get your pretest work. Okay? Okay. I'm going to go ahead and start screen sharing with you guys so we can work on our notes for today. So I'm on page 7. It says end behavior up at the very top. And find that screen share button. And this is what I want to share with you guys. Okay. So here are our notes. Okay, yours should look just like mine, except for you probably don't have a purple sticky note in the middle of yours. So your homework from last time, and I haven't seen you guys in a full week. The last time I saw you guys was Tuesday of last week. But your homework from then was to watch a video that Mrs. Laundrie put together that was a sort of a short introduction to end behavior. So the big idea from that video was that on our coordinate plane, we have our x-axis and our y-axis. We know as we move on the x-axis, these numbers are getting bigger, right? Here could be 1, 2, 3, 4, blah, 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 blah. And we're getting bigger and bigger and bigger and bigger and bigger, eventually getting to this idea of infinity or positive. On the other way, we have negative numbers. So we're doing the same thing, but with our negative numbers. So technically, we're getting smaller and smaller and smaller and smaller down to eventually negative infinity, right? And our y-axis, the orientation is at 90 degrees, right? The orientation is different because we're vertical instead of horizontal. But that idea of these numbers are getting bigger, heading towards positive infinity. And as we go down, these numbers are getting smaller, heading towards negative infinity. That idea is the same. And so when we talk about end behavior, we're saying, as my x values get really big towards positive infinity, or as they get really small towards negative infinity, what are those y values doing? Okay. Polynomials, we are essentially asking, where are the arrows pointing? We'll look at some functions next semester where we've got functions that could do other things. They can kind of level out as they get towards 3 or as they get towards whatever. But for our polynomials, we're just looking at functions that are either going to go up or down. Okay. So these are, I just sketched in the graphs on page 7. So if you've done that already, great. If not, you can copy down my sketches. If you did this already and your paper doesn't look exactly like mine, that's okay. None of these like axes are labeled, so this is just a sketch. So if you sketched yours a little bit differently, as long as it has the same general shape, we're fine. So what we've got here are a bunch of different polynomial functions, okay? We're going to talk about their degree, and then we're going to talk about their end behavior. Okay? So degree, remember we talked about the other day. Oops. If I have standard form, which we do for each of these, right? Everything multiplied out, and I'm in order based on the exponents, right? Biggest exponent first. Our degree is going to be that biggest exponent. So for this first function here, our biggest exponent is a 2, so our degree is 2. For this next guy, our biggest exponent is 4, so our degree is 4. And for this last guy, our biggest exponent is 6, so our degree here is 6. Okay. This bottom row, I don't see an exponent here. Remember, since I don't see an exponent, that means that it's 1. Just like if you didn't see a coefficient, it would be 1. So our degree here is 1, and then 3, and then 5. So this top row has all even numbers for degree. This bottom row has all odd numbers for degree. The other thing I want you guys to notice is that our leading coefficient is positive. for every single one of these functions. Sometimes it's just one, like here it's just one. Here we've got two, it's a little bit more exciting. But all of these are starting off with positives. I'm not starting with a negative sign on any of these functions. Okay, that's going to come into play a little bit later. So now let's talk about their end behavior. Okay, so when I talk about end behavior, what I want to know is as I plug in x values more this way, are the y values getting bigger, going up, or are they getting smaller, going down? So essentially, we're just looking at which way do the arrows point. So for this end of my function, as I plug in x values more and more this way, I'm getting y values that get bigger and bigger and bigger, right? Those y values are going to keep getting bigger. That's why this arrow is pointing up. Okay? So on the left end of my function, when I plug in more and more negative numbers for x, okay, right? Here's where x is negative. Here's where x will be positive. When x is negative, when I keep plugging in negative numbers farther this way, my arrow is pointing up because my graph is going to keep going up. That means my y value is going to keep getting bigger. If my arrow points up and my y value is getting bigger, then we say that y is approaching infinity. Or you could put in positive infinity if you like that better. Okay. On the other side of my graph, on the right side of my graph, when x is positive, right, when x is going towards infinity, when I plug in bigger and bigger and bigger numbers for x, the farther out I go, the bigger those y values are getting. So they're getting bigger and bigger and bigger and bigger, and y is going up and up and up. And this arrow tells me y is going to keep going up and up and up. If my arrow is pointing up, my y values are getting bigger. That means y is going towards, again, positive infinity. And you could put the positive sign or not, doesn't matter. But that's all that means. That's what we're talking about when we talk about end behavior. If we were to look at the box right underneath it, the 2x minus 3, okay, right here, again, this portion of your end behavior is always going to look the same. We're just going to fill in the blank for the y part. So here we're saying when x is negative, on the side of the graph where x is negative, where's it going? Where's that arrow pointing? Okay, so if I look at my arrow, it's pointing down. So as I go farther this way, this graph is going to keep going down. My y values are going to keep getting smaller. When our arrow points down, that means we're going towards negative infinity, right? Back to this little like coordinate plane sketch that I had. So if your arrow is pointing down, that means your y values are getting smaller, and we say we're approaching negative infinity. If your arrow is pointing up, that means your y values are continuing to get bigger, and so we say we're going towards positive infinity for those y values. Okay. On the other end of our graph down here, this arrow is pointing up. If it points up, we're going towards infinity. And that's all we're really filling in here. If my arrow points up, we write infinity. If it points down, we write negative infinity. Okay? So let's take a look at the last couple on this page. So on the left end, when x is negative, right, on the left side, when x is negative, my arrow is pointing up, so that's positive infinity, or just infinity. On the right side, when x is positive numbers, when we're going towards positive infinity for x, my arrow is pointing up, so that's, again, positive infinity. That's all we're filling in for end behavior. Okay. Same thing over here. On the left side, right, that's when we see negative infinity for the x portion of it. On the left side, our arrow points up, so that's infinity for the y. On the right side, right, this describes the right side. Our arrow is again pointing up, so that's again infinity. And if you like positive infinity better, that's fine too. And then same idea down here. Okay. On the left, when x is negative, this time our arrow is pointing down. When your arrow points down, that means we're going to negative infinity. Just like on the y-axis, the negative values are down and the positive values are up. Okay, that's all we're looking at. What am I pointing towards? On the right end, this arrow is pointing up, so that would be positive infinity. And then same thing over here for our last graph. Give this one a try and we'll recap in just a second. Okay, on the left side, right, when x is negative, my arrow points down, so that means y is going to negative infinity. On the right side, when x is positive, my arrow points up, so that means we're going to positive infinity. I'm going to stop screen sharing for just a second so I can check the chat and see if there's anything in there. I don't see anything new. Okay. Remember, if you have a question, please unmute yourself and ask. Okay, so I'm going to go back to sharing my notes page. There we are. And then on the next page, on page 8, exact same thing, okay? If you need to, go ahead and sketch in those graphs. But again, we're going to look at degree for each of these. We're going to look at its end behavior. And then I want you to notice that all of these are starting off with negatives. We have negative leading coefficients for each of these. The degrees are actually the same as what we saw on the last page. So degree of 2, degree of 4, degree of 6, degree of, if I don't see it, it's a 1, degree of 3, and degree of 5. Okay. So if we're looking at the end behavior, remember this first chunk of it is exactly the same. This is just copy pasted in every single box on this page and on the last one. The thing that will change based on our graph is what we fill in here for the y portion. So on this first one, on the left side, when x is negative, our arrow is pointing down now. So that means we've got negative infinity. Y is approaching negative infinity. That's our end behavior. On the right side, when x gets to be bigger and bigger positive numbers, our graph is going down. Okay? The farther we get from the origin, the graph is going down. When we go down, that means we're approaching negative infinity. I want to point out that when we talk about end behavior, we don't care about what's happening in the middle of the graph. We care about where those arrows are pointing on the ends of our functions. So like I have all kinds of crazy stuff going on in the middle of some of these. I don't care about the middle stuff. I don't care how many bumps or wiggles or squiggles or whatever weird things are happening in the middle. I just care about the arrows at the end. It's end behavior. Okay, this next guy, both ends are pointing down. So that means y is approaching negative infinity on each end. Over here, our last one on the top, both ends again pointing down, so y is going to approach negative infinity. As we come down to this next row, I've got opposite things happening with my ends here. On the left end, when x is negative, right, over here's where x is negative, this arrow is pointing up. Since we're going up here, that means that we are approaching positive infinity. Here we're going down, so that means we're approaching negative infinity. And if it helps, give yourself that little reminder. So if you need to jot that in your margin, jot that in your margin. On the next one, on the left side, when x is negative, again, our arrow's pointing up. So that means we're going to go towards infinity. Or if you like that positive sign in there, positive infinity. On the right side, when x is positive, y is going down. Our arrow is pointing down. So that means we're approaching negative infinity. And then on this last one, again, on the left end, arrow is pointing up. So that's approaching infinity. On the right end, arrow is pointing down. So that's approaching negative. Okay. This is the key here. If your arrow points up, infinity. If it points down, negative infinity. Okay, that's the big idea for end behavior. Okay. Now there are a couple generalizations that we can make based on what we've seen here. So if I have a polynomial, I'm looking at the bottom here. If I have a polynomial that has an even degree and a positive leading coefficient, that would be like this top row. from the last page. Positive degree, or positive leading coefficient, even degree. Notice our ends are all going up, okay? That's not a coincidence. My general shape then is going to look something like this. And you may have weird, crazy things that happen in the middle, but both your ends are going to point up. When you have an even degree and a negative leading coefficient, I want you guys to think about the graph transformations that you've seen before. If I stick a negative in front of a line with a positive slope, now it has negative slope. If I have a parabola, right, what you guys saw at the very end of your algebra 1 step, if I have a parabola and I give it a negative leading coefficient, it flips upside down, which is what we saw here. So where I have an even degree, but a negative leading coefficient, now both of our ends are going to go down, okay? When I have even degree, the ends go the same way. And if they have a positive leading coefficient for my function, the ends go up. If it's negative, they go down. For the odd degree polynomials, notice that our ends are opposite for the negative leading coefficient and for the positive leading coefficient. Odd goes opposite. If the degree is odd, the ends go the opposite ways. When our leading coefficient is positive, it's got a general like positive slope to it, if we could think of that. If I were just to connect the ends, it would look like something with a positive slope. So where we have an odd degree and a positive leading coefficient, the general trend is up from left to right. Remember, odds go opposite. Those odd degrees with a negative leading coefficient, like these guys, our general trend is going to be down, okay, like a line with negative slope. So we know because it's odd, our ends go opposite. If it's negative, I'm going to think of something with a negative slope. Okay. I'm going to stop sharing so I can hop to the chat for just a second, see if there's anything new. There's not. Okay. So if I know that if I know the degree and the leading coefficient, I don't actually have to graph the thing to know what the end behavior is going to look like. So if we turn to the next page, this first function has an odd degree. I know that means the ends are going to go opposite. My leading coefficient is positive. There's no negative sign in there like there is over here. So that means I'm going to have opposite ends in a general like positive direction. So my graph's going to look like this. Weird stuff in the middle, but those are the ends. So the left end is going down. This would be negative infinity. The right end is going up. That would be positive infinity. And that's all there is to end behavior. Okay. If I take a look at this next guy, number 3, even means they're going to go the same direction, even degree. Since my leading coefficient is positive, they're both going to go up. Since they're going up, that's infinity or positive infinity. If I've got a problem like number 5, where I don't have it all multiplied out, you can distribute this through, or remember we can add those exponents and we would get a degree of 3 here. Since the degree is odd, the ends go opposite. And since it's negative, our general trend is going to be down from left to right. So on the left side, we're going up. That's infinity. On the right side, we're going down. That's negative infinity. That's end behavior. Okay. I'll go through a couple more examples, but before we're done for today, I want to mention your homework assignment. It's listed on Google Classroom already, but it's a video just like we've been doing. It's about x-intercepts. You're going to watch it on Delta Math. So before, the video has just been linked right on Google Classroom. You have to go to Delta Math to watch this one, and it's going to be over your notes on pages 19 and 20. Okay, so I know the end behavior video was a little bit different because it didn't match right along with your notes. This one goes right through with your notes on pages 19 and 20. Again, you have to watch it on Delta Math. So you're going to have to log in there to be able to see it. And again, virtual study hall with Mrs. Stone from 1:20 to 1:35 today to go through more end behavior problems. I'm going to go through a couple more, but I know that we're almost out of time. So if I take a look at just a couple more examples here with a couple minutes that we have left. Let's say I take a look at number 4. I have standard form here. That means my degree is that biggest exponent. Okay. My degree is 3. That's odd. Remember, odds go opposite. Probably tired of hearing me say that by now. And then negative leading coefficient means it's going to be a general downtrend. The left end, the arrow is pointing up, so that's going to go to positive infinity. The right end, it's pointing down, so that's going to go to negative. Let's see if I've got one. Let's take a look at this guy right here. Another one where you could distribute if you wanted to, or we can add those exponents. 3 and 1 would be a degree of 4. Since it's even, our ends will go the same direction. Positive leading coefficient means both ends will go up. So we would have infinity and infinity. Again, that video on Delta Math over your notes on pages 19 and 20 is your homework assignment. We are skipping some stuff in the packet, okay? I know that. So we're on page 9 right now, and your notes are on 19 and 20. We're skipping a couple things. Some of it we'll come back to a little bit later. If you have questions, you are welcome to shoot me an email. Even though Mrs. Stone has sort of that open walk-in office hour Google Meet link posted, you are still welcome to email me, and I'll be here for virtual office hours as well. If you have questions over anything, please let me know. For those of you that had issues with Google Classroom, I see I have some emails. I'm sure some of them are from you guys. If you have questions on submitting things on Google Classroom or a hard time with anything, shoot me an email and we'll try to troubleshoot. And I will see you guys next time.